Hi and welcome to our example video on electrostatics and the net electric field. So what I'm going to look at here is just an example from a past paper and show you how simple that really actually is. In the first question they ask us, two positive charges A and B are located near a point P. Okay, so there's a point P. In the diagram they are in line with point P in diagram 1. So here we can see they're in a straight line. But in diagram 2 they're at an angle of 90 degrees. And now they make a 90-degree angle with P here. Okay. In question 7.1 they ask us describe an electric field. And an electric field is simply an area in space where a unit charge will experience a force. Okay. Question 2. Calculate the net electric field at point P in diagram 1. So a net electric field, we're assuming that point P has a charge of Q, and we must calculate the net electric field. Now we saw in the previous video that when we have charges on opposite side of my unit charge, then we must take the difference between the two. So the net electric field in this case will be the difference between the electric field of A and the electric field of B. And the reason why I'll take the difference between the two is because they're on either side, so they will work against each other if they have the same charge, and together if they will have opposite charges. So that's why we use the difference. Okay, so the electric field is simply K times charge of A divided by the distance between Q and A squared minus K, the charge of B divided by the distance between Q and B squared. Okay, and then we see according to the information they gave us, and I've got limited space, but right here, so K we know is 9 times 10 to the power of 9 times Q, the charge here is 5, a positive charge of positive 5 microcoulombs. So we can use microcoulombs as long as we keep micro in our final answer when we give our answer as force per coulomb. Okay. But now here it is important to realize that microcoulomb means times 10 to the power of negative 6. So I can't use microcoulomb because, and the main reason because K doesn't have microcoulombs as in its units when it cancels out. So we must still times 10 to the power of negative 6. Okay, it's a positive, so we can keep it as a positive, divided by, and then we'll divide by RA squared. So the distance here must be in meters again, and we are already given meters, 0,4 squared. And then for B, we're subtracting B's, that's 9 times 10 to the power of positive 9 times the charge here, this time is positive, it's 3 times 10 to the power of negative 6 because it too is in microcoulomb, divided by the distance between this one is 0,35 squared. Okay, so what answer do we get for this one? 9 times 10 to the power of 9 times 5 times 10 to the power of 6, negative 6, is equal to that divided by comma 4 squared, is equal to 281, 250, 281, 250 minus 9 times 10 to the power of 9 times 3 times 10 to the power of 6 is equal to 270,000 divided by, or 27,000 divided by 0.33 squared is equal to the 220440816 220408116, and now the difference between them means I give this one a negative plus 281250. That looks wrong. 281250 is equal to 60841,84. 60841,84 Newton per Coulomb. Okay, now this is a positive answer, which means if I give it, if it's a positive answer, it means that this one is winning. Okay, the first electric field, this one is stronger, and it is a positive, which means it will repel Q, and so Q will move in the direction of B. So this is this towards B, okay, so in other words, if I get a positive answer, it will repel from the first one, or you could have said away from A. Okay, so that's my second question. Sketch the electric field pattern around the charges in diagram 2. So in diagram 2 we've got the same charges, and we see, just want to use a different pen. Okay, so we'll see we've got charge A here, and we've got charge B here, and we see the charge A is slightly larger than charge B, which means that if we but they have the same charges. So first of all, what we'll need to do is just draw a middle line between them, but because charge A is slightly larger than charge B, the middle line won't be in the center, it would be slightly off center. Okay, because this one is a 5 positive, this one is a 3 positive. So the forces that they will exert will be, or the repulsive forces of 5 will be further away than the repulsive forces of 3. And I say repulsive because remember we're considering positive charges. So here is my center line between the two, and I must just make sure that an object that is here won't experience any net force. Okay, so the charge from here, if I had a charge here, it would go away from there and then be pushed away in that direction. Okay, charge from here will move straight away, and then the effect of 5 will work in on it. A charge here will move away, and then the effect of 5 will move it away. A charge on this side will perfectly just be pushed away in both directions, because now if Q is on this side, 5 and 3 is rejecting it. Okay, here 3 will push it away, and then the charge of A will start having an effect. Here 3 will push it away, but then the charge of 5 will have its effect. Here 3 will push it away, charge of 5 takes its effect. Okay, here 3 will push it away, but 5 will also push it away, so it will have an effect like that. I don't think this is very difficult. This is fun. Okay. Here we go. Charge effect is pushing it away a little bit. Okay. Same thing here. The only difference here is that the force of 5 will have a stronger effect until I get closer to the force the effect of charge B. Okay, so here, if I'm here, it will push it away and then push it in that direction. Now let me just do it a little bit closer. It will come a little bit closer before it goes away. Now just again, I have no lines here in the center because there's no force here. I can't draw anything in the center. So notice I'm not doing anything in the middle here, and again, I'm not happy with that. Okay, there we go. Here it will push it away. There it will push it away, and then the charge of 3 will have its effect. There it will push it away straight, and then the charge of 3 will have its effect. It will push it away, and then charge of 3 have its effect. Push it away, and the charge of 3 has its effect. Okay, here the charge at the back again in this direction, 5 will push it away and 3 will push it away, so it will just be a straight line. Here 5 will push it away, and this charge effect will have a slight effect. That's even too much. Okay, have a slight effect. There we go, that's slightly better. And here we'll push it away, slight effect. Okay, there we go. I think that's a very good picture of the electric field pattern around charges in diagram 2. Calculate the net electrostatic force that charges A and B exert on each other in diagram 2. Now that one is just the force calculation. So for example, force is equal to K times QA times QB divided by R squared, where K is 9 times 10 to the power of 9, QA is plus 5 times 10 to the power of negative 6, and plus 3 times 10 to the power of negative 6. And now what is the distance between the two? Okay, that is now in diagram 2. The distance between these two, oh, I didn't think of that, but the distance between these two charges, notice these two charges, this forms a triangle, a right angle triangle, so we need to calculate this distance, is the square root, I'm using Pythagoras, the square root of 0,4 squared. Actually, I'm going to use R squared. So in other words, I don't even need to take the square root, so I'm not going to. So remember that this side, let's call it R. R squared is the distance between AP, so AP squared plus BP squared. And so when I calculate that, that's 0,4 squared plus 0,35 squared. And I don't need to take the square root. I'm not looking for the distance, I'm looking for the square distance, so I don't need to take the square root there. So this is simply just 0,4 squared plus 0,35 squared, and that gives me 9 times 10 to the power of 9 times 5 times 10 to the power of 6, the negative, times 3 times 10 to the power of 6 with a negative is equal to, that's my numerator, and so in my numerator 0,135 divided by my denominator, just want to make it slightly simple, 4 squared plus 0,35 squared is equal to 0,2825, 0,2825. So what is the force that these two are experiencing? So so this, if I just 1 over x, that just means I'm using the reciprocal of that, in other words, to make it the denominator, times 1.35. Okay, that's what I get, 0,4. I'm going to use 3 decimal places. I like to use 3 decimal places if there's nothing in front of the comma. 0,478 newtons. That's the effect that they have on each other. So remember, both of them, they're repelling each other, and this is the force wherewith they so you can just say away from each other. Okay, excellent. That is me. If this was a negative answer, it would have been towards each other. That is me for this example. Thank you for watching. I hope you enjoyed it. Hope you learned something. We'll see you in another example video coming up soon.